So hello everyone, I'm here with something a little different. Sorry. This is a very good site, Conceptis puzzles, and they have a variety of puzzles. Here is the nonograms. They have some number logic as well. Kakuru is very nice. But I usually only do these picture logic ones. I really like this Pix. It's probably my favorite, but it has to be advanced logic. So today I think I'll do some Block-a-Pix. They release one for free of each type every week, so go check them out. They are all very nice. Advanced Logic Pix is also very hard, very challenging, and very nice to do. But both, I believe, free puzzles of Pix and Pix are basic logic, and they are kind of meh. So Cross-a-Pix is very hard. I will not play it on video because it will take really long. You have you have to really check every single column and row because the solution usually every single time it lies in a single column and a single row. You have to find it precisely. It's not like nonograms where you can find various cues in the columns and rows that work. So that's enough talking and go to Block-a-Pix. And the free one is, well, it's fairly easy, 20 by 20, but you can get the idea. So I had a little technical issue. I forgot that the Windows Capture tool that I use, it cannot work with two different windows. So when I click to play the puzzle, it opened it in another window. So I basically did not record myself solving it, but I hope it worked this time. So let's go. The idea behind Block-a-Pix is you must put each of these numbers in a rectangular square with rectangular block. Sorry, every square is a rectangle, but not every. You get idea. So we must put each number in a rectangular block that contains the same number of squares as the number that is inside it. And each rectangular block can only contain one number. So all the ones are trivial. They are only the block painted. I have an easy way to deal with them. Autofill starting clues. Okay. So now, usually it's easier to start with the big ones. There are some trivial small ones as well, like this tree. Trees can only be a linear 1 by 3. So you can only go 3 up because you can't go to the sides nor downwards. So let's check for easy small ones. See this tree. It does not fit here to the right, so it must go upwards. Alright. Anything else? This two can only go down. Let's start with the big ones. See this 12. Usually a 12 can go 1 by 12, 2 by 6, or 3 by 4. We cannot go any further in the vertical axis, so we must go at 1 by 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oops, 1 too many. Okay, so now we count from here as well. It ends up in the 12. So let's go to the 28. 28 can be 1 by 28, 2 by 14, or 3 by 7. Because these are, oh, I'm sorry, 4 by 7. So 1 by 28 cannot fit. 2 by 14 also we cannot fit. Cannot go 14 this way or this way. So we are left with a 4 by 7. Now it cannot go 7 vertically, so vertically must go 4 tall. We cannot go down, so it must be in these 4 rows. Now horizontally it must be 7 wide. So let's count. It can only go until here. So 1, 2, 3, 4, 5, 6, 7. And starting from the right, 1, 2, 3, 4, 5, 6, 7. Now this 6 here, it must be linear. We cannot go to the right or to the left. So 1, 2, 3, 4, 5, 6. This 6 as well, it must be linear, because a 6 can go 1 by 6 or 2 by 3, but the 6 does not have a space for a 2 by 3. It can only go 2 by 2 at max, so it must be linear. And now we have defined the 6. It goes down all the way. So this 28 ends here, and this 12 goes all the way to the border. 7s are fairly easy. They can only be a 1 by 7, because 7s are only divisible by 1 and 7. So it must be like this. So this 7 cannot be placed vertically, so it must be horizontal. Now 1, 2, 3, 4, 5, 6, 7, 6. Okay, so this 6, this is the only available space for it. This 4 must be a 2 by 2. Cannot go forward like this, cannot go forward like this. And the only way it can go 2 vertically and 2 horizontally is here and here. Now this 9 is also defined. 9s can be 1 by 9 or 3 by 3. It does not have space to go 3 vertical, so it must be a 1 by 9. And it is all the way. Okay, so this 2 must go like this. What else? Let's go for the 27. 27s can go 1 by 27 or 3 by 9. Obviously it's not a 1 by 27, so it must 3 by 9. It can only go 9 horizontally. There isn't space for it to go 9 vertically. So vertically it must go 3 tall. And now let's check for 9 wide. It can go up until here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It fits perfectly in the space. So the 3 must go up. The 5 must go at least until here. So this 2 goes here, this 2 goes here. This 14 cannot go 1 by 14, only has 11 space available, so it must be a 2 by 7. The 2 cannot be in this direction because it also doesn't have space, so it must go 2 horizontally. And if it goes 2 this way, it cannot extend 7 vertically, so it must go this way and all the way down. Now this 8 can only be a 1 by 8 or a 2 by 4. 1 by 8 does not work, so it must be a 2 by 4. Now this 4 for sure is like this. This 4 for sure is a 2 by 2. 7s only go linear, so 6, 7, and the 5 is done. This 6 is also done. This 4 here can only be a 2 by 2. This 2 here, this 3 only has this space available. This 9 must be a 3 by 3. It cannot be a 1 by 9. It only has 5 vertical and 5 horizontal to go. So it must be a 3 by 3. And the only way it can go 3 by 3 is like this. So this 4 must be a 3 by 2. This 2 goes here. This 4 can only be a 2 by 2. It cannot go forward like this, cannot go forward like this. So it must be like so. Now this 6 can only be a 2 by 3 and only in this way. So this 2 must go here, this 3 must go here. This 4 here, it must be a 2 by 2. It cannot go forward like this, and it cannot go forward like this. And it must go 2 vertically, and it must go 2 horizontally. And the only way it can go 2 vertically is going 1 down. Now we don't know if it goes left or right, but we know that this must be painted. So this 6 cannot fit here, so it must be a 2 by 3. The only way it can go 2 by 3 is like this. Now this 3 is horizontal, this 3 is also horizontal. Now this 4 can go like this. Okay, so 14 must be a 2 by 7. So 1, 2, 3, 4, 5, 6, 7. This 9 can go there. Check this 12. 12s can go 1 by 12, 2 by 6, and 3 by 4. It cannot fit in a 1 by 12 configuration, nor in a 2 by 6. Not enough space. So it must be a 3 by 4. The only ways it can go 3 by 4 is like this or like this. But if it goes in this configuration, it blocks this 9 here. So it must be like this, so this 9 is linear up until here. Alright. The 7 is fairly easy. Can only go linear and in this direction. Alright. The 6 here can only be a 2 by 3. Now that same thing as with this 4 here. It must be 2, must go 2 or 3 vertically. We don't know yet. And it cannot go up, so it can only go down. And it can only go 2 blocks. So it is 2 tall and 3 wide. Now it can go 3 wide, starting from here and ends here. Starting from here ends here, okay? Now this 9 must be a 3 by 3. Cannot go 9 like this. And the only way it can go 3 by 3 is like this and like this. Because the 3 blocks it horizontally and the 14 vertically. Now this 8 must be a 2 by... Oh, there's something easier. Let's start with the 10. The 10 can go 1 by 10 or 2 by 5. It cannot go here in this case 1 by 10, so it must go 2 by 5. So it must be 2 here because there isn't space to be a 5, and 5 this way. Now this 3 is done, this 3 is done, 14 is done. This 12 can only go 1 by 12. Let's check. 11, okay, so like this 3 is done. This is the only space left for the 8. One thing I noticed in this Block-a-Pix puzzle, every single square is usually occupied by a rectangle, but I don't believe that's in the rules of how to solve them, so I do not use that as a logical thinking way. So this 2 is done. This 3 can only be like this. This 6 goes here, this 2 goes here. This 6 can only be possible in this configuration. This 6 must be linear. It cannot be a 2 by 3 because it doesn't fit, so it must be like this. So this 2 can only go here, this 2 can only go here. Alright, almost there. This 4 can only be a 2 by 2, so this 3 is done. This 3 is both extend to the right. This 3 can only be like this. And to top it off, the 4. That's it, a bookbinder. It's a fairly nice picture. Not cannot really expect much from a 20 by 20, but I hope you enjoyed the puzzle solving, and I will see you next time with an onogram by Belko61. Goodbye.